Hello to all. My name is Samiksha Godalkar. I am assistant professor in SMD College of Engineering, Yeola. I was taught the subject of basic electronics. In last video lecture, we see the FM demodulator detector types. Firstly, we see the balanced demodulator. In this video lecture, we see the second type is balanced slope detector. What this circuit is done? This circuit uses two slope detectors connected in back-to-back fashion to operate as off-center type transformer and hence fade 180 degree out of phase. In balanced slope detector, the top secondary circuit is tuned above the IF frequency by amount del F and bottom circuit is tuned below IF by del F. Each circuit is connected to diode detectors with suitable RC loads. The output is taken across series combination of loads so that it is sum of the individual outputs. The balanced loop detector diagram consists of a transformer. Input is given to the transformer winding. After that, the two diodes are used, diode D1 and diode D2. The center tap transformer is used here. At the output of diode, we use in both two diodes. The output is resistor is connected to the diode. At the output of resistor, we connect to the capacitor, and at the output voltage, we get across the resistor and capacitor. The balanced slope detector transform curve is the input voltage. Input characteristics is output of T at Fc plus del F, output of T at Fc minus del F, output of T at Fc plus del F, which is negative voltage at Fc plus del F. At Fc minus del F, the output is negative. The combined transfer curve is as shown in a slide. The Fc plus del F in positive side and the Fc plus del F is on negative side. This is the combined transfer curve of balanced slope detector. We see in this detail. When the input frequency Fc is the input frequency, output of T positive is equal to output of T is negative. So the sum of output of T and T is equal to 0. When input frequency Fc plus del F, then the output of T positive is greater than output of T negative. So sum of output of T and T is positive. When input frequency Fc minus del F, then output of T positive is less than output of T is negative. So sum of output of T and T is negative. What are the drawbacks of balanced slope detector? Even more difficult to tune as there are 3 different frequencies to be tuned. Amplitude limiting still not provided. Linearity, although better than single slope detector, is still not good enough. The Foster-Seeley phase discriminator is the next type of FM detector. First is balanced slope detector. Second is slope detector. After that, balanced slope detector. And third is phase discriminator. In this, all the tuned circuits are tuned to the same frequency. The balanced slope detector circuit with some changes is used. This circuit yields far better linearity than slope detection. The phase discriminator diagram is as shown in a slide. As C and C4 are coupling and RF bypass capacitors respectively, therefore VL3 is equal to V in. So voltage across diode is equal to V in plus secondary voltage divided by 2. This is the phase discriminator on process. The phase discriminator equation is now in transformer voltage is induced in the secondary as a result of current in primary, and VAB is equal to Jm upon L1 Vin into XC2 upon R2 plus JX2, where X2 is equal to XL2 minus XC2. The phase discriminator at resonance, that is when input frequency is FC, X2 is equal to 0. VAB is equal to Jm upon L1 Vin into XC2 upon R2, that is VAB leads Vin by 90 degree. The phase discriminator phasor diagram is as shown in a slide, where the VA0 is equal to VB0, hence the discriminator of phase discriminator output is 0. When VA0 is greater than VB0 as shown in a slide, hence the phase discriminator output is positive, and when VA0 is less than VB0, then the phase discriminator output is negative. These are the three phase discriminator output we see here. The next type of FM detector we see in next video lecture. Thank you.